In today's video, we're going to look at percentages and reviewing what you've learned in lower school and making sure that you're up to scratch for applications. Now, people in Year 12 struggle with some of the non-calculator work, particularly focusing on percentages, decimals, and fractions. And it's really important if you do have issues with any of these that we sort them out in Year 11 because you don't want them to become issues in Year 12. So we're going to be focusing on syllabus point 1.1.5 in this video. So we're going to be able to apply percentage increase or decrease in context. In context is quite important, so referring to the fact that you're going to have to read a question and work out what percentage calculation you're going to need to have to apply. We're going to talk about inflation and wages. We're going to talk about percentage markups and discounts. That's something you should have definitely focused on in lower school, including GST, which potentially could be new, and calculating profit and loss in absolute or percentage terms, and calculating simple and compound interest is also part of this syllabus point. However, we'll touch on that a little bit later on. We need to cover the profit and loss and simple and compound interest. That will be all done in part 2. So we're going to start with a percentage review. So hopefully you recall that percent literally means per 100. So when we're talking about percentage, we're talking about a certain portion of this 100. So for example, if you had 64%, that is equivalent to 64 over 100, which is also equivalent to 0.64. So in applications, it's a prerequisite to know your conversions between percentages, fractions, and decimals. If you're struggling with that, the time to fix it is in Year 11 because you have more time. We have more flexibility in the curriculum, whereas Year 12's mandatory. We have to stick to what we give you and there's a shorter time frame. So it's better to get on top of this work now. What I have for you below is a conversion chart that you can use. Unfortunately, of course, you don't get notes pages in non-calculator sections, but you can use it to practice your skills. Potentially the hardest part of this, depending on your skills, is this part here, the decimal to fraction. Can sometimes get a bit tricky in a non-calculator situation. That is when you would come up here and follow these steps. So if we practice an example, let's say you were given 0.623. So the final digit in this one is the 3. So looking at that, the 6 is in the tenths, the 2 is in the hundredths, the 3 is in the thousandths. So that's the first step, working out that that's in the thousands place value. We're going to put the decimal value over the final place value. So it's going to be 623 over 1,000. And then we would simplify the fraction. In this case, it can't be simplified. So that would be your final fraction. So that's again falling on your place value. Again, a prerequisite for application. So any of these skills in the videos that come up which you're not sure about or you want some further clarification, that's when you need to come and see me so we can fix it now. The previous chart, we're looking at the decimal to percentage. We will times it by 100. So we're going to look at some of the skills required from the syllabus. So the first one is expressing an amount as a percentage of some total amount. Now most of you would be quite familiar with this skill. This is like converting your test scores into percentages. So again, you'll need to be able to do this without and with a calculator. Obviously, the easier numbers will be without a calculator and some of the more complex with a calculator. So we'll start with something a little bit more simple. So let's say we wanted to express 18 out of 40 as a percentage. So most of you would be quite comfortable with the calculator work. So if you had a calculator, you would do 18 divided by 40 times 100, and that would give you 45%. So that's all well and good when you have a calculator, but now we need to work on some non-calculator skills. I'm going to show you both the long division and the short division. Most of you will be more comfortable with short division, so we'll start with this one. They both really do the same thing. One's just, I believe, set out a bit nicer and does the remainders nicer. But it's up to you which one you use. It's your maths. So non-calculator, we set it up and we're doing the 18 divided by 40, which is how many times does 40 go into 18? So obviously you're looking at it and thinking, well, 40 doesn't go into 18. So this is when we need to add a 0. Now we can't change the 18. We can't willy-nilly change numbers in maths. So we can add a 0 and make it 18.0. So now you're asking yourself, well, how many times does 40 go into 180? Hopefully you know that 4 times 4 is 16, which then means that 40 times 4 is 160. So 40 times 4 gives you 160. We know that it goes in 4 times. We need to reflect that we've added a decimal below, so that's 0.4, and that there's a remainder of 20. We add that in up here. Now, because there's a remainder, we have to keep going. So we add an additional 0. So now we need to check, well, how many times does 40 go into 200? Well, hopefully you know that 4 times 5 is 20, which means that 40 times 5 is 200, and 40 times 5 gives 200, therefore we would put a 5 up here. There is no more remainder, so that's the decimal. The last step would be to convert this decimal to a percentage. Now going back, so we're going to take this 0.45 times 100, and we know that times 100, we move the decimal place 2 places to the right, which gives us 45%. So that's the short division. It's probably what you're used to. The only difference between that and long division is a slightly different setup. So same starting point. So we go 40 into the 18. Again, we say that 40 can't go into 18. In this case, we actually put a 0 to represent that can't happen. Then we say, well, 18 take 0, and we do a subtraction. 18 takes 0, whatever this top value is 18. So just to make it a bit more clear, whatever this value is becomes what you subtract. And we recognize that we need to keep going, so we add a decimal there, a 0, and we drop the 0. Now we ask ourselves, how many times does a 40 go into 180? We know from the previous example it goes in 4 times. All right, now what we do is we say, well, what's 40 times 4? So 40 times 4 is 160. We put this here and we subtract. All right, so we multiply the 40 by the 4, and that gives us 160. Then we do a subtraction. So 180 take 160 gives you 20. Add another 0, drop it. How many times does 40 go into 200? That gives you 5. So that gives us a decimal value of 0.45. Times that by 100, which gives us 45%. So I prefer the long division, but that's because I'm used to it. If you like the short division, doesn't matter, but you need to be able to do one of the two. The last type of question that you could be asked in this sort of realm of expressing an amount as a percentage of some total amount is if you get a commodity or something that's increased and they ask you what's the percentage increase. So in this case, we've got the original price of whatever this was 1,640, and the new price is 1,846. And it wants us to know, or wants us to calculate the percentage increase. So to start with, what we need to find out is, well, what is the increase? So we're going to take the original price from the new price. So the increase is going to equal 1,846, subtract 1,640. That gives us a difference of $206. Now we want to know, well, what is the percentage increase? Now the increase came off the original amount. So we want to know, well, what is this $206 as a portion of the original amount? So we're going to say, well, what is 206 over the original amount of 1,640, sorry. So we've got the original price being here and the increase is here. And we know to convert that to a percentage, we're going to have to times that by 100. Now, we would put that into our calculator. I very much doubt this would be in a non-calculator situation. Put that into our calculator and we would get the 12.56%. Now, this is where you would check the rounding. Most of the time with percentage increase, it does require 2 decimal places, occasionally 1. Rounding is something you need to make sure that you're clear on as well. So another skill point that you need for applications. So moving along. So now we move into the real parts of the syllabus. So finding percentage amounts will lead into increasing and decreasing percentages, GST, and percentage profit and loss. So finding percentage amounts. So these are the sort of questions where you'll get where it says find, let's say, 27% of $60. Now, what we need to first talk about is the fact that percentages really are quite useless to use in calculations. Yes, some calculators come with a percentage button, and I frequently go to shops and see shop attendants try and use that percentage button, but most of the time it doesn't work. Really what you need to be thinking is, well, I want to convert this percentage. That does nothing for me. I either want it as a fraction or I want it as a decimal, okay? So I want it as something as a decimal. Now, I prefer to work in fractions because that's just the sort of person I am. Most of you are more comfortable with decimals. Again, it depends on whether this is a calculator question or a non-calculator question. If it's a calculator question, highly recommend a decimal. It's probably much quicker for you in the end. If it's a non-calculator question, the fraction is probably going to be your friend. So again, like before, we did both. So let's start with the calculator version. The first thing you want to do is convert that 27% into a decimal. So for a calc. So again, you can refer to that flow chart that I showed you before, but to do this, we divide it by 100. So we do 27 divided by 100. Remembering that that just moves the decimal point 2 places to the right. So that would equal 0.27. Once you've got the decimal equivalent, you would do 0.27 times 60. Remembering that of means times in maths. So if it says 27% of $60, you're thinking 27% times 60. Okay, so recognizing that times. And that would give you the $16.20. Okay, so 27% of $60 is $16.20. Don't forget your units. They're silly little marks that can add up a lot in an exam situation. So non-calc, working with fractions instead. So the first thing I would do is convert that percentage into a fraction. So again, referring to the flow chart, to convert a percentage to a fraction, you put the percentage over 100. Okay, so we would do 27 over 100. Again, times, of means times, so we would do times. Now 60 doesn't really help us when we're working with fractions. When you're working with fractions and you're doing operations with fractions, make everything a fraction. It makes it so much easier. Now any whole number as a fraction is over 1. So this would be times 60 over 1. Now some of you would be looking at that going, why? That looks so much worse than it did before. What have you done? But there are steps we can take to make it easier. So the first thing I do is check the diagonals. So what I'm doing by checking the diagonals is seeing if there's a common factor that I can take out of the equation to make it a more simple sum. So if I check the 27 and the 1, so the first diagonal, there's nothing there for me to do. There's no common factor. However, if I check the 60 and the 100, there hopefully for most of you is quite an easy common factor that we can take out, which would be 10. So what you can do there is divide both of them by 10. So that becomes 27 over 10, times 6 over 1. Now straight away for most of you, that becomes a lot easier. The only hard part is the 27 times 6. That is when you probably want to go to your algorithm, so 27 times 6. So 7 sixes are 42, we carry the 4, 2 times 6 is 12, plus 4 is 16, so it'll be 162. So we're going to have 162 over 10, okay? Now all we need to do is do that division. Now we have a base 10, that's quite easy. I move the decimal point one place to the left, okay? So that's going to give me 16.2, which I know in this context is $16.20. So you can see that we arrived at the same answer, one being a calculator and one being a non-calc. And I can't stress enough that you need to be able to do this to do applications well, particularly in year 12. So this follows on to increasing and decreasing something by a given percentage. With this work, there are two methods to do either way. So we'll start with increasing, we'll show you both methods, and then we'll work on decreasing. So let's say you are asked to increase $450 by 24%. All right, so there are two methods. I like to call them the one-step method and the two-step method. Obviously, in terms of exams and timeframes and testing, I obviously recommend the one-step method. However, if you feel more comfortable, you can do the two-step method, either or. So, first of all, the two-step method, we'll start with the two-step. The first step would be to work out what 24% of 450 is. Now, for the ease of this video, I'm just going to use the calculated method. Obviously, you could do the non-calc method here as well. So we've got 450 now times for of, and we want 24%, which would be 0.24. Now, if we calculate that, we would get $108. So I know that 24% is 108. Step 2, because this is an increase question, we're going to add that amount on to the original amount. So we'll do 450, and we're going to add, because it's an increase question, $108. Now 450 add 108 gives us the $558. So that's the two-step method, okay? Probably not the one I recommend, but it still works. There's nothing wrong with it. It just takes a little bit more time. Now, the one-step method is actually considering, well, what have I done? If I've increased it by 24%, what do I actually have there? So what we're thinking is, I've increased it by 24%. So this is sort of a thinking step, if you like, which means it's 100% plus 24%, which means I'm actually looking at 124%. Okay, that's all done in your head. That's not technically a step. So if I increase something by 24%, I'm literally looking for 124% of something. So then you go straight to the calculation. So the step 1 and the only step would be 450 times, now 124% as a decimal would be 1.24. And if you multiply that straight away in your calculator, you'll get the 558. So you can see the difference. Obviously, it depends how long it takes you to get that step sorted in your head. If that takes too long, then maybe you should stick with this two-step. It's up to you, whichever one you feel more comfortable with. Now, decreasing is very similar. Obviously, you're subtracting, you're taking things off, however. So let's say you want to decrease $62 by 34%. Okay, so we're going to decrease. Again, there are two steps, two ways to do it. The first one is the two-step. So first step would be working out what is 34% of $62. So we'd do 62 times 34% as a decimal would be 0.34, which gives us $21.08. Then step 2, because this is a decrease question, we're going to subtract. So we would do 62 subtract the $21.08, which would give us the $40.92. Again, there is a one-step method to do this, technically two if you thinking about what you're doing. Now I'm decreasing by 34%, which means I'm doing 100% subtract 34%, which leaves me with the 66%. So you're effectively asking what is 66% of $62. So the one calculation, if you like, is 62 times 0.66, which gives you straight away the $40.92. So that's increasing and decreasing something by a given percentage. So to finish off this video, we're going to focus on finding the original amount. So basically, we're going to tie GST into this. So GST of any product being sold in Australia is 10%. So sometimes what you would like to do is, once you've bought something, trying to work out, well, what was the cost before GST? And you might think it's as simple as taking the amount and going, well, okay, what's 10% of that amount? And I'll just subtract that. But it actually is not that case, because if you think about it, we've added 10% onto something and got a new amount. 10% of that new amount is not effectively 10% of the original amount. It doesn't work. So what we need to think about is, well, what did we do to the original amount to get this actual amount, and then work backwards. Finding the original amount is one of the trickier percentage skills, and students struggle with it. So hopefully working through this today will help. So let's say I went and bought something and the final cost was $522.50. And I wanted to know, well, what was the amount before GST was added? So I couldn't just work out 10% and subtract it, because that's 10% of this new amount. I want to work out what the original amount was. So what I think in my head is, well, I had this amount, let's call it a box. I could use algebra, but let's stay away from that for now. Now, to increase that by 10%, I would have multiplied that by 110%. So I'm thinking 110%, well, as a decimal, that's 1.1. So I would have multiplied it by 1.1, and that would have given me the $522.50. So now what I need to do is work backwards to find out what that amount was. Now, if I multiplied the original amount by that, I need to do the opposite to go backwards. So what I can summarize is, well, this original amount will be $522.50 divided by 1.1. So if I do that on my calculator, that gives me the original price being $475. So the amount in the invoice prior to the GST being added would have only been $475. So to find the original amount, your first step is basically you need to work out what the multiplier would have been. So work out what the multiplier, I'm just going to write the times, would have been. So in this case, it was 1.1. To increase something by 10%, I would have multiplied by 1.1. Step 2, divide amount by multiplier. Okay, so that's just in short. So if we try another example of this question, we'll try a decrease one. So let's say I bought a shirt and I look at my receipt and it cost me $36.98. And I know it was listed as 30% off. And I wanted to know, well, what was the original price on the shirt? How much did I actually save? Again, I can't just go and 36.98 divided, like I can't do that. I need to work out what I've actually what was the multiplier so I can divide by that. So again, I'm thinking, okay, well, I had this shirt. Now 30% off, again, we're thinking, well, 30% off is the same as 100 take 30, which would be 70%. So I actually paid 70% of the value of the shirt. So I would have multiplied it by 0.7, and that would have got me the $36.98. So to work backwards, I will need to do $36.98 divided by 0.7. Now, if I do that, I get the $52.83. So we'll split this video into half. We'll do the part 2 to cover the other